Okay, let's do a science investigation related to heaviness. So we've picked objects up and estimated the heaviest to the lightest. So that's a really good exercise. And then you can verify your finding by putting them on the scales and recording the mass. Were you correct? It's a good idea to be able to sort of get a sense of the heaviness of an object by just estimation in your own hand. But now what we want to do is make this into a proper science investigation. And what we said was, if you're going to do an investigation fairly, what we've got to be able to do is plan properly and fairly all of the things that we need to do in the experiment that make the results valid. So our observation is that some materials feel heavier than others. So that's something you just recognize by holding the objects in your hand. Our challenge is to design an experiment to investigate this observation. The heaviness can be recorded in gram. Now, I've written it out there because that's the original spelling of the word gram. Usually people abbreviate it to G-R-A-M and then give it a symbol G. But, you know, that was the original unit there, gram. Of different types of material of the same size. And by size, we mean the volume, the space they take up. So we're going to compare different materials, but of the same size. So let's do that. So when you look through all the materials, you see, that's not going to work very well, is it? Because they're all different sizes and you would have to spend ages sewing them, cutting them, and then measuring them in order to get them the same size. Well, it just so happens that I can pick out 3 from my list where that's fairly straightforward. And I've got a piece of plastic, a piece of metal, and this particular metal's copper. There are other metals, of course. And I've got a piece of wood. And it just so happens that you can get those in a regular size, and they're fairly simple to try and cut up so that you can get them the same volume. So the space they take up, lengthwise, widthwise, diameter-wise, is the same. So that makes it a fair test. Well, just doing your estimation again, straight away you feel that's definitely the heaviest. Oh, that's a bit more difficult. Very difficult to figure out because much lighter objects we just aren't sensitive enough to be able to do it. But that's a piece of plastic, that's a piece of nylon plastic, and that's a very simple piece of wood. So let's do our comparison then. Get a table ready just as before. So what you'd have to do is record the mass in grams, material name or type, mass in grams. So there's your little table, material name or type, and its mass in gram. So let's have a look. So we've got, what's that, 28 grams for the stick of copper. I'll just write those down. Take that one off. The stick of plastic. You're joking. Just zero the scales and try that one again. So that's been recorded as 4 gram, and that was a stick of nylon plastic, 4 gram. And now our piece of wood, set back to 0, 2 gram. Fabulous. Fabulous. So now we've got an experiment where we'll be able to record results, the mass in gram, and be able to say, yeah, even though they're the same size, somehow the copper's got heavier material within it. How does that work? You would think, you know, everything's made of atoms, that's what we're told. Well, surely you get the same amount of atoms in each of the materials because they're the same size. Well, maybe that's something for a further investigation. How on earth can a metal be so many times heavier? Look at that. A little bit of mathematics. How many times heavier is copper compared to nylon? So we're saying how many fours are there in 28? Times table. 7 fours are 28. Seven times. So copper, pieces of the same size, are 7 times heavier than nylon. And nylon is twice as heavy as wood for pieces the same size. Now it just opens up a new investigation, very difficult one to perform though, and we're saying to ourselves, well, what on earth are these really made from, right the way down on the atomic level, and how are those little atoms arranged in these materials such that this one is so heavy compared to those two? 3 different types of materials. What's so special about metals? Where do they get their heaviness from? How can such a small piece be so heavy? Great experiment. It can be repeated time and time again. If you have blocks of materials of the same size, and we've got a piece of foam there, these are all plastic, a piece of foam, a piece of nylon, and a piece of acrylic plastic, they're all plastics. And then you can look at the same sort of thing again, so we can compare their size. Here's an interesting thing about the foam. Oh no, we'll leave it for another video.